For the integers, if you go one level above the rational numbers, or one level above the whole numbers, you get integers. Integers do negative numbers. Okay, so well, they introduce negative whole numbers. So when you have your natural numbers here, we went up to the whole numbers. Whole numbers introduce 0. Anything to the power of 0 is 1. Now, if you put a negative number in the little box up there, what it does to the big box, it flips it. So if you had 5 in the big box and negative 3 here, what the negative number would do, it would put it 1 over 5 to the power of 3. So you use up the negative to flip the number 5. Okay, and if the base number, if this number is in the bottom to a negative power, what it does, it kicks it up. If it's a fraction in the big box, what it does, it flips it. The bottom goes up top and the top goes to the bottom if you have a negative exponent. Okay, so let's talk about integers, negative numbers. Negative numbers, a to the power of negative 1. And negative power means if the number is on the top, you kick it down. That's the base. So what this means is this goes down and becomes 1 over a to the power of 1. So if you had a to the power of negative 2, this would be 1 over a squared. Now, it also works the other way around. So if it's on the top, that's a negative power, it kicks it down. If it's in the bottom, and if it's a negative power, it kicks it up. So if you had 2 over a to the negative 3, well, the negative power down here kicks the a up top. So this becomes 2 to the power of 2a cubed. Now this cube only applies to the a because there's no bracket here saying it applies to both of them. So keep track of your variables and your numbers. Don't do operations to numbers that they're not supposed to be done to. This also applies to a fraction. So if it's up top, if it's a negative power, it kicks it down. If it's in the bottom, negative power kicks it up. Well, if it's a fraction to a negative power, it just flips it. So if you had a over b to the negative 2, okay, all that does is deal with the negative number. It takes the a, kicks it down, it takes the b, kicks it up. So this would be b over a to the power of. After the integers, we had rational numbers. Now, rational numbers are basically fractions. Any number that repeats or terminates is a fraction. Okay. So the way it works with fractions is, if you have 2 over 3, the denominator in the exponent becomes a radical, becomes the root. So if, okay, let's take a green. I'm going to do this thing right down here, okay? So if you have any number in the base and put it to a fraction, what happens is the top number in the fraction is the numerator, I think that's what they call it. That acts like the natural numbers, or the whole numbers. Well, you wouldn't put 0 in the fraction. That acts like natural numbers. So the top number, it just clones whatever is in the base, okay? The denominator in the exponent goes to the root. So for example, I'm going to do 5 to the power of 2 over 3. Let's do that. So what do we got? Let me go over here. We got 5 to the power of 2 over 3. The way it works is that 3 in the denominator moves to the radical in front of the 5, okay? It'll be like 2 more minutes. Okay, awesome. So the way it works is we got a skater over there who wants to skate. He's being nice, taking a break. So what we got is 5 to the power of 2 over 3. And what it does is it grabs the 3 in the denominator and moves it to the front of the 5, and it becomes the radical, okay, the root symbol. So that's the way rational numbers work. works is a to the power of 2 over 3. And if you want to write this in radical form, okay, this would be, you take the 3, you move it up front under the root symbol, okay? So this would be the cube root of a squared. Make sense? What if you had, you could go the other way around as well. What if you had the 5th root of a to the power of 10? Well, the way this works is, this number here goes in the denominator in the power. So this would be a to the power of 10 over 5. And 10 divided by 5 is just 2. So the answer to this would be a squared. Okay. So this rule, this property helps you to reduce, to evaluate things, simplify things. Let's do a few more so this really sinks in. Because if I said, hey, what's 4 to a power of a half? Well, we talked about it, and you should know by now that the 2 here goes in the root symbol, so this is just the square root of 4. Now, what does the square root of 4 mean? You should have already told me that the square root of 4 is 2, right? The way it works is, this radical, this root symbol here, is a boundary. And the way it works is, the number here tells you what's required to go past this boundary, either this way or this way. Right now, this is a root. That was a 2. So this just means square root of 4. Square root of 4, you break it down into its prime factors. So what the radical here means is, for you to go from the inside out, you need 2 things that are the same and 2 things combined to become one thing. So you pair these guys up, these guys come outside of the root symbol, and 2 roots coming out, there's nothing else left in there. So square root of 4 becomes 2. Now, this applies to any number that's in the root. So for example, actually let's do one more square root first. Let's say if I said, hey, what's 8 to a power of a half? Well, 8 to a power of a half is square root of 8, right? Yeah. Square root of 8 is, let's see what it is. It's 2 times 2 times 2. Now, as we said, this radical symbol here, this root symbol, because that's a 2, there's no other number here, it means you're looking for pairs. So you start pairing up your numbers. So 2 2's can come out of this symbol, move this way as a single, so they join together. So 2 2's become a 2. And what's left inside the root symbol? Inside the root symbol, you still have a 2 left, so you can write it down there. So 8 to a power of a half is a square root of 8. A square root of 8 becomes 2 root 2. Now that, if you remember, is an irrational number because it's the root of a prime number. That means the number there doesn't end or repeat. So it keeps on going, changes up, no pattern to it. So this applies to any radical. So for example, what if you had, what's the cube root? What's the cube root of 8? Well, as a power, that would have been 8 to the power of a third, right? So that would be the cube root of 8. Well, 8 you can break down into prime numbers, which are 2 times 2 times 2. For in this case, this is a cube root. So what that means is you're looking for triplets. Triplets. So you combine 3 things that are the same. There's 3 2's here. So the rule is, the boundary or the toll for you to go from the inside out, you need triplets. Triplets become 1. So these 3 2's come out of this, and they become a 2. Now you took everything out of the root symbol, the cube root symbol, so there's nothing left. So the cube root of 8, or 8 to a power of a third, is a cube root of 8, which is just 2. Then you have 27 to the power of 2 over 3. Now if you remember, if you want to crunch numbers, reduce numbers, or simplify things, you want to reduce the numbers first instead of making them bigger, right? Remember when we were doing multiplying fractions, you didn't multiply all the numbers up top, multiply the numbers on the bottom, and then break into the prime numbers.
kill them, right? What you did was kill whatever you could kill and then multiply things up. So the same type of principle works here. When you're evaluating numbers, simplifying numbers, what you want to do is reduce them first and then make them bigger if you have to. So